A 5-year-old boy walks into the Swallow of Spring chocolaterie. He says, "I want 1 blue chocolate, 3 red chocolates, 5 green chocolates, 7 yellow chocolates," and so on. So you want the first 10 odd numbers? Let me add them so I can charge you. The 5-year-old surprises him, saying, "Let me help you add the first 10 odd numbers. Let's start with the 1 blue chocolate. Form a 2 by 2 square by placing the 3 pieces of red chocolates around the blue chocolate. Form a 3 by 3 square by placing the 5 pieces of green chocolates around the red chocolate. Form a 4 by 4 square by placing the 7 pieces of yellow chocolates around the green chocolate." And so on. Until we form a 10 by 10 square by placing the 19 pieces of teal chocolates. Aha! At every stage we had a square. And now we have a 10 by 10 square which sums to 100 pieces. The story is made up, but the famous Russian mathematician Kolmogorov, at the age of 5, published in his school magazine, Swallow of Spring, that the sum of the first n odd numbers is n squared. Information and picture source: Wikipedia. Key learnings: 1. We turned a summing problem into an easier geometric problem. 2. A lot of beautiful mathematics is about transforming a problem to something that makes the answer obvious. 3. The sum of the first n odd numbers is n squared. The idea behind summing the first n odd numbers is neat, and can be extended to even numbers. But there's another powerful idea: using replication and rotation to simplify addition. Let's say we want to sum the numbers from 1 to 15. Let's create a copy of the same series. Now we have a rectangle with 15 plus 1, or 16, in each column and 15 columns in all. For example, the third column has 3 blue and 13 orange, making a total of 16 in that column. So sum of what's in blue and its rotated copy, in orange, is 15 plus 1, times 15, or 16 by 15. So what's in blue must sum to 16 by 15 divided by 2, which is 120. Using the same idea, we see that sum from 1 through n is n plus 1 multiplied by n divided by 2. This identity shows up in many places, so it's worth remembering how we obtained it. Sum 1 through n equals n plus 1 multiplied by n divided by 2.